Okay, a 2 microfarad capacitor and a 1000 ohm resistor are placed in series with alternating voltage source of 12 volt and frequency of 50 Hz. Calculate the current flowing, the voltage across the capacitor, and the phase angle of the circuit. Okay, so first of all, for this question, we need to identify what component we have in the circuit. Okay, what component we have the circuit. So as you can see, here we have the capacitor and the resistor. Yeah, capacitor and resistor. Capacitor and resistor. So this is what kind of circuit? This is a RC circuit. This is an RC circuit. Yeah, RC circuit. So this is important to know it is an RC circuit, because later on when we want to draw the phasor diagram, then we will know. Okay, let me draw it out. Yeah, let me draw it out. Later we will need to draw a phasor diagram. Okay, this is the x-axis and this is the y-axis. And where is the current? Current is over here. Okay, current is always at the x-axis. Maybe put this as IRMS. Okay, so this is an RC circuit. RC circuit. So for we can say that resistor is always in phase. The voltage across the resistor is always in phase with current. Yeah. So this is VRMS R. Okay, VRMS R. And then for capacitor, capacitor is always below. Yeah. Capacitor is always below. Maybe you can if you look at this diagram, the inductor VL always on top, the capacitor is always below, and then VR is always in phase with current. VL is at the top, VC is at the below. Yeah, or we can actually just say that maybe we can say like this. If you remember, if a resistor is always in phase, if capacitor is ice, yeah? the acronyms. Let me write it down. Ice, and then L is LE. L is LE. Yeah. So capacitor is like, you see the C at the in the middle. Inductor is like the L at the middle. So for capacitor is always the current leading the EMF. Current leading the EMF. Inductor is always EMF leading the current. Like that. Yeah. This one is for capacitor is current lead voltage. Actually, EMF is like voltage. It's like voltage. Or this one should be VC lah. For this one, LE. LE, this E is VL. Okay. So ICE and LE. So for capacitor is current leading voltage. For inductor is voltage leading current. So since this circuit we have resistor and capacitor, so current is always at the x-axis. So resistor is in phase. That means the voltage of resistor is always in phase with current. But for capacitor, capacitor is ICE, or current leading voltage. Current leading voltage. So the current is always in front. So we actually we know that this rotation is anti-clockwise. So current is in front. That means if for capacitor is current leading the voltage. So current is in front. The voltage for capacitor is behind. This is the voltage for the voltage for capacitor. Yeah. So current is in front of current is leading voltage across capacitor. Okay. Like that. So it's always VL at the top, VR at the x-axis, VC at the bottom. So since this circuit we only have resistor and capacitor, so you only have VR, and VC. You only have VR and VC. So for capacitor is current leading voltage. So it's the current IRMS leading the voltage capacitor. Capacitor is behind, you see? Capacitor is behind the current. Because this is rotation anti-clockwise, so current is in front of the voltage capacitor. Okay, current leading. Yeah. So I hope you understand. We don't have VL. Because this circuit only has capacitor and resistor. There's no inductor. You see that? There's no inductor. Okay, enough. So this is the diagram. So okay, so in fact we have we can draw three kind of diagrams. Yeah, if you notice, we can draw three kind of diagrams. We can draw like hold on a second. We can draw three kinds of diagram. So just now is if using root mean square value. If root mean square value, then all is root mean square value. If you use peak value, then all these are peak value lah. All these are peak value. This is a V0, V0, and this one is I0. This is V0R. This is a V0C. Okay. Or sometimes we also can change it to resistor. We can change it to resistor. We can change it to resistor or XC. Yeah, can change it to resistance, reactance of capacitor, or capacitive reactance. We can use the peak value, everything peak value. We also can use all root mean square value. Okay. If this root mean square value, then this VRMS total up, then we will get this. This should be the VRMS source. So if we total up the VRMS R with VRMS C, we will get VRMS source. Pythagoras theorem. Okay. If peak value, then when we total up, you will get this peak voltage for source. Peak voltage for source. Pythagoras theorem. Yeah. And then if you use all resistance, the total up, you will get Z lah, impedance. And then for all these, you also can find the phasor angle. You can find the phase angle, which is this one. This here you can see there is a you need to find the phase angle later on, which is the phi. What is phase angle? If you look at the notes, phase angle is, what is phase angle? Phase angle is the phase difference between current and voltage. Between I and V. This voltage is V source, current and V source. Okay, that's a phase angle. Phase angle is phi. Yeah. So that means it's between, what is a phi? Phi is between the current and V source. Phase angle phi is phase difference between current and V source. Between current and V source. So this is the phi. So or you can also use this one also, between current and V source. That is the phi. You understand? Or you want to find the current between current and impedance. Between current and impedance. That is a phi also. This is also phi. Understand? Because this impedance is actually the same place as V source. This one, the impedance is actually the same place as V source. Understand? It's just that we use all resistance, reactance, then we have impedance. If you use all voltage, this one will be V source. Okay, so this angle also phi. Yeah, all these have the same angle. All these three diagram, they have the same angle phi. Phi is the phase angle. Yeah, it's called the phase angle. Okay, so this is the diagram for RC circuit. RC circuit. RC circuit is only at the x-axis, and VR is always at the x-axis. VC always below the y-axis. Yeah, VC always below the y-axis. Okay. Remember, in R is in phase, capacitor is I's, inductor is LE. Remember that. Okay. So now, okay, let's do the questions. So here he gives us the 2 microfarad. What is this value? This is not XC. Yeah, this is not XC. It's wrong. It's not XC. It's not the reactance yet. This is just the capacitance. Capacitance. Understand? And this is the resistance. 100 ohm is the resistance. Okay. This is just a capacitance because it's microfarad. It's not ohm. Understand? So if you want to find XC, you need to use the formula. What formula? You want to find the XC, you need to use 1 over 2 pi FC or 1 over omega C. You need to use the value. You need to use a formula XC equal to 1 over omega C to find the XC. Yeah. So this is just a look at the unit. The unit is microfarad. Microfarad is capacitance, not reactance. Yeah, not reactance. Okay, be careful. Okay, so we have the capacitance, resistance, and this is the source. You see that? This is the source. The source voltage. So this is 12 volt. Okay, this is a peak voltage or root mean square voltage. So which one? Is this a peak value or root mean square value? If not specify, remember, if the question not specify, then it's default. It's default value. Then it's default value. So what is default value? Default value means is root mean square value. Root mean square value is either, you know, if you not specify means default value. Default value is always root mean square value. Root mean square value or is either root mean square voltage or root mean square current. Okay, it's not peak value. It's not the V0 or I0. Okay, so this one he didn't specify is peak value or root mean square value. So it's by default root mean square value. Okay, so we should write here, this one, it should be the 12 volt. It should be root mean square value. Root mean square value, and it is a source value. Yeah, source voltage. Okay, so root mean square source voltage. Which is this one? Which is this one? Root mean square source voltage. This one. Okay, 12 volt. And then we have the frequency here. This is the frequency. Okay, now you want to find the current flowing. Current flowing. So he didn't not specify. So it's by default the root mean square current. Okay, it should be the root mean square current. So you need to find the root mean square current. Root mean square current. Okay, and then B, voltage across capacitor. So not specify, is it peak voltage or root mean square voltage? So it should be by default root mean square voltage across capacitor. So we need to find this one, VRMS C. We need to find VRMS C. Okay, and then phase angle is the phi. Yeah, phi is the angle between. Okay, phi is the angle between what? Between the V source. Is angle between V source and current. Understand? Or you can say between Z and R lah. Yeah. because R is in phase with current, So that's that is what we call phase angle. That is what we call phase angle. Okay. Phi is the angle between V source and current. Okay. Okay. Let us first find the XC. We will need this value XC. Okay, XC is 1 over omega C. Omega is 2 pi F. Omega is 2 pi F. Okay, put in the value. 2 pi. Frequency is 50 hertz. 50 hertz. What capacitance is 2 microfarad. Micro is exponent negative 6. Micro is exponent negative 6. So 2 exponent negative 6 farad. Okay. Okay. Calculate the value. Let's calculate the value. 2 pi multiply 50 hertz and then multiply by 2 exponent negative 6. Exponent negative 6. So 1 over answer. So the answer is 1591.54 just 549 is enough lah. Okay, 549 ohm. This is the capacitive reactance. We got it already. Okay, now we want to find the current. Okay, so how do you think we can find the current? I think we can find, we have the resistance, we have the capacitive reactance. I think we can find the impedance. Okay, is there any use for finding impedance? Yes, we can find an impedance. Okay, we can find impedance, and then we can use the VRMS source to find the current. That means, you know what? I think I can use this one. To find the current, I need the root mean square current, isn't it? Root mean square current. So look at this summary of equations. I think we can find the impedance. We can find the impedance out of these XC and resistance. Out of XC and resistance, I can find the impedance. So once I got the impedance, and also the question already provide us the VRMS source, 12 volt. VRMS source, I can find the root mean square current. Understand? So use this summary equation. This summary of equation is very good. I think you should write it down. Yeah, take down these notes. Take down these notes. All these important equations. Understand? All these are important tricks that I provided to you. You should take down. Yeah, you should take down all this. Okay. So yeah. So I definitely need to find the impedance. So find the impedance first. Yeah. So why I need to find the impedance? Because I can find the root mean square current out of this formula. Understand? There it is. Yeah. So I can find then I can find my root mean square current, which is needed by the questions. Okay. First, he already provide us the VRMS source, so we need to find the impedance. We already got XC and R. We got the XC and R already, resistance. So I can find impedance using this diagram. Okay. So I think I can use this. I can use this diagram. Okay. Can use this diagram. Okay. So now. So to find the impedance, okay. So okay, let's find the impedance first. Okay, let's find the impedance. So just now the resistance is what? What's the resistance? Resistance is 1000 ohm. See, 1000 ohm. So can write it down. 1000 ohm over there. It is 1000. Let me write using blue color. So this is 1000 ohm. Okay, and then the XC I got is 1591.549. Okay, this one. this is XC 1591.549 ohm. Okay, so I can find the Z. This current you leave out from the equations, because to find Z, this current is not involved. This current is not involved. What involved is only the resistance and capacitive reactance. Okay. So we only Pythagoras between resistance and XC. Okay. Let's calculate. Yeah. So Z is actually Pythagoras between R square plus XC square. Okay. Which is just take the 1000 square plus 1591.549 square. Okay, let's calculate 1000 square plus 1591.549 square, square root, and so the answer is 1879.635 1879.635 ohm. Okay, so that's the impedance. So I got this impedance ready. I can use this formula to get the current. Okay, let's calculate now. Okay, I got this already. Okay, so the VRMS source is 12 volt. 12 volt. So put in the 12 volt there. So this is the 12 volt, and impedance is 1879.635. So what is the IRMS? So 12 divided by 1879.635. So the answer is 6.38. 6.38 exponent negative 3 ampere. That's the current. So I got the root mean square current already. Is that the answer correct? Is the answer correct? 6.38 exponent negative 3. 6.39 negative 3. That's correct. Yeah, almost. 6.39 negative 3. 6.38 negative 3. Is this correct? It's correct. Okay. So that's the first part. That's the first part. That's for question A. Okay. That's for question A. I got the current ready, root mean square current. Now, okay, be careful. This is the RC circuit. Yeah, RC circuit. Okay. Now, how about we want to find the voltage across capacitor. So how to find that? Once we have the current, we can easily find the voltage for other component. You understand? Because once we have the current, we can find voltage for resistor, voltage across resistor, voltage across capacitor, voltage across inductor. Important is we need to find the current first. Once we got the current, we can find voltage for other component. We can also find the peak voltage. We can also find peak voltage resistor, peak voltage capacitor, peak voltage for inductor. Or we want to find root mean square voltage for resistor or capacitor or inductor. We can also find peak voltage or root mean square voltage. Okay, get the current first. So I got the current already, so I can get the voltage across capacitor. Now, question B, I put it over here. So voltage, I want to find root mean square voltage for capacitor. Use the formula root mean square current XC lah. Understand? This is actually the basic formula from what? From the V equal to IR. You know, this Ohm's law. This is what we call Ohm's law. Ohm's law. Now it's voltage across capacitor. That's why we use the resistance across the capacitor. If VC, then it's XC. If VR, then is resistance R. If VL, then is XL. Understand? This one. If VR is R, if VC is XC, if VL is XL. Okay. If Vsource is Z. If Vsource is Z. Very important summary. Okay. Okay. So let's calculate. Okay. I have the IRMS already. Just now I calculated IRMS. So which is 6.38 exponent negative 3. 6.3 exponent negative 3. XC. What is XC? XC is 1591.549. Okay, let's calculate. 6.38 exponent negative 3 multiplied by 1591.549. Okay, so which is you know, is 10. Oops, is 10 point 10.154. 10.154 ohm. No, voltage. This is voltage. Okay, so is the answer correct? Yeah, it's 10.2 volt, 10.2 volt, or 10.154. So correct. Yeah, so that's my root mean square voltage across the capacitor. Okay, 10.2 volt. That's correct. Okay, now I want to find the phase angle. Phase angle for a circuit. So phase angle phi. So what is phase angle? Phase angle is phi, angle between voltage source and current. Okay, so how to find this phase angle? So how to find the phi? How to find this phi? Phi is actually between phi is actually angle between Z and R. Z and R, or V source with current. Okay, so it's very simple. This one you can just, you know, you can actually just you can either, okay, this is a C. So C, let's do the question C. So C, I want to find the phase angle, which is phi. Yeah, so is angle between Z and R. So this phase angle, you actually, you know, just use this you know, cos phi, the power factor, you know, the R equal to Z cos phi. I say, what I can say is, you know, there are several ways. There are several ways to find phi. Yeah, several ways to find phi. It's just Pythagoras theorem. You can either, you know, phi is the angle between R and Z, or current I with V source. So you can actually just maybe, you know, just use cos phi. Cos phi is equal to, you know, cos phi is trigonometry. You know, trigonometry, adjacent over hypotenuse. R is adjacent. R is adjacent. Z is hypotenuse. R is adjacent. Z is the hypotenuse. Okay. Or you also can use, you know, this phi is you can also use tangent phi. You know, tangent phi is opposite over adjacent. Opposite is XC. Opposite XC. Adjacent is R. You can also use XC over R. There are several ways, you know. Is opposite over adjacent. Opposite over adjacent. Okay. So in fact, this one is after you put it, rearrange your formula. Rearrange your formula, you actually get this R equal to Z cos phi, isn't it? Actually this is R equal to Z cos phi. Yeah. Which is, you see this formula, R equal to Z cos phi. R is equal to Z cos phi. You see? R equal to Z cos phi. Yeah, just Z multiplied to the top. Yeah. So you can either use cos phi or you can also use tangent phi. Let's use both formula. See whether we can get the same answer for phase angle. Okay, let's use both formula. So resistance just now is what? Resistance is 1000 ohm. Okay, resistance is 1000 ohm, and then impedance is 1879.635. 1879.635. Okay. Okay. So let's calculate and see. Let's calculate and see. 1000 divided by 1879.635. Remember, if you want to find phi, you need to anti-cos. Anti-cos the answer. This one, 1000 divided by 1879, you get certain answer. To get phi, you need to anti-cos. Remember, change it. I forget to change to angle. I forget. This one, you need to change to degree. Don't maintain as radian. Don't maintain as radian. Your calculator need to, your calculator need to set to degree. I forget to set to degree. Yeah, your calculator need to set to degree. Set to degree. Okay. So okay, remember to anti-cos. So 1000 divided by 1879.635. Okay. So anti-cos the answer, which is okay. So I got my phi is let's calculate. So my phi I got after anti-cos I got 57.86 degree. 57.86 degree. Or you use tangent phi also can. Tangent phi, you should get the same answer also. XC is 1 phi. It's all trigonometry, trigonometry. Opposite over adjacent. Opposite over adjacent. Divide by this one. Adjacent is 1000 ohm. Okay, 1000 ohm. Remember this one, you need to anti-tangent. You need to anti-tangent. Anti-tangent. Okay, so 1591.549 divided by 1000, and then I need to anti-tangent my answer. So I got the answer also. From this one, I also got 57.86 degree. 57.86 degree. Okay, so you see, I get the same answer from cos phi or tangent phi. It's all simple, simple trigonometry method. Yeah, trigonometry method. So is the answer correct? Answer correct? Yes, it is. It is 57.9 degree. 57.9. Is it correct? 57.9? Yeah, 57.86. Almost there. So you can use cos phi or tangent phi. Normally people use cos phi lah. Easier, yeah. Okay. Better the answer in degree rather than in radian. Yeah. Better you put the answer in degree. Yeah, normally you put in degree. Okay, so the answer is correct. So that's how we do this question. Very simple for this chapter. This is the main questions. Yeah, this question only have resistor and capacitor. We don't have the inductor yet. Yeah, we don't have inductor yet. Okay, so that's all for these questions. Okay, bye bye.